To find the critical numbers of the function f of x equals 2x minus 3x to the 2/3, we certainly need to know what critical numbers are. Well, critical numbers are x values where the derivative equals 0 or where the derivative does not exist. Critical numbers are important values in a function's graph. All local extrema occur at x values that are critical numbers. In this graph, there is a local maximum value, or relative max, about above x equals -3. Therefore, x equals -3 must be a critical number. Additionally, there is a local minimum value, or relative min, at about x equals 3. This means that x equals 3 must also be a critical number. However, not all critical numbers are associated with local extrema. For example, the function with the associated graph has a critical number at x equals 0, but as you can see, there is not a max or a min at this point. Now that we know what critical numbers are, let's find the critical numbers of f of x equals 2x minus 3x to the 2/3 power. Since critical numbers occur at x values where the derivative is 0 and where the derivative does not exist, a good place to start is to first find that derivative. This function has two terms, and I can use the power rule to differentiate each term individually. The derivative of 2x is 2, and the derivative of 3x to the 2/3 will be, well, I'll bring the 2/3 down to the front and multiply it by the coefficient of 3, and then decrease the power by 1. 2/3 minus 1 is -1/3. I have the derivative at this point, but the second term in the derivative can be simplified. 2/3 times 3 is just 2, and I'll rewrite x to the -1/3 as x to the +1/3 in the denominator of that fraction. It will be easier to find the critical numbers if I get a common denominator and combine these two terms. Here, the common denominator between 2 over 1 and 2 over x to the 1/3 is x to the 1/3 power. Writing the first term over x to the 1/3, I have 2x to the 1/3 over x to the 1/3, and the second term remains unchanged, 2 over x to the 1/3. Now, I will combine these two terms and write it as one fraction, 2x to the 1/3 minus 2, all over the common denominator, x to the 1/3 power. I finally have a simplified derivative, so now it's on to finding the critical numbers. To find the critical numbers, I will first find the x values that make this derivative equal to 0. When your derivative is a fraction, like this one, remember that the only way a fraction can be 0 is when the numerator is 0. So to find where this derivative is 0, I will first set the numerator equal to 0. The algebra to now isolate the x is fairly straightforward. First, add 2 to both sides of the equation to find that 2x to the 1/3 power equals 2. Then, divide both sides of the equation by 2. 2 divided by 2 is 1, and I now have x to the 1/3 power equals 1. To eliminate a power of 1/3, you can raise both sides of the equation to the reciprocal power. The reciprocal of 1/3 is 3, so raising both sides of this equation to the third power will isolate x. This leaves me with x equals 1 to the power of 3, which is still 1, so x equals 1 is the solution to this equation. X equals 1 is the value that makes the numerator 0. X equals 1 is the value that makes this derivative 0. X equals 1 is a critical number. Now, let's find the x values where the derivative does not exist. Division by 0 is undefined, so when your derivative is a fraction, like this one, the derivative will not exist when the denominator equals 0. So to find the remaining critical number, we'll set the denominator of the derivative, x to the 1/3, equal to 0. This equation can be solved in one step. Like the other equation, x can be isolated by raising both sides of the equation to the third power. And since 0 to the third power is still 0, I have x equals 0, which is the x value where this derivative doesn't exist, meaning that x equals 0 is also a critical number. Therefore, our original function has two critical numbers, x equals 1, the value that made the derivative equal to 0, and x equals 0, a value in which the derivative does not exist.